Imagine spending hundreds of billions of dollars on buildings designed for a technology that changes completely before the concrete is dry. That is the risk hiding inside the AI data center boom. In 2025, capital spending by 5 major technology companies passed $400 billion. The International Energy Agency expects that combined figure to jump another 75% in 2026. That money is buying chips, servers, networking, cooling, land, and access to electricity. It is a physical bet that demand for cloud AI will remain enormous for years. A bubble does not require AI to disappear. It only requires the industry to build more expensive cloud capacity than customers can profitably use. The technology can win while some investors lose. Chapter 1. The biggest infrastructure race in technology history. Microsoft expects roughly $190 billion of capital spending during calendar 2026. Alphabet expects between $175 and $185 billion. Those are company forecasts, not the whole industry. Alphabet says roughly 60% of its infrastructure investment goes into machines such as servers, while about 40% goes into longer-lived data centers and networking. The short-lived technology sits inside a very long-lived shell. The International Energy Agency projects global data center electricity consumption will more than double to about 945 terawatt-hours by 2030. AI is the largest driver of that growth. A data center can sometimes open within 2 or 3 years. The grid, transformers, turbines, and transmission lines supporting it can take much longer. Companies are reserving tomorrow's electricity before tomorrow's demand is known. Chapter 2. What the builders are betting on. Training creates a model. Inference uses that model to answer people. Frontier training needs enormous clusters, but inference ranges from a tiny phone feature to a complex agent consuming serious cloud compute. Right now, the demand is real. Microsoft says it expects cloud capacity to remain constrained through 2026, even while it brings more GPUs, processors, and storage online. That is the strongest argument against an immediate bubble. CoreWeave shows the scale of the new infrastructure market. At the end of 2025, it reported 43 data centers, more than 850 megawatts active, and about 3.1 gigawatts of contracted power capacity. Long-term, take-or-pay contracts can protect a provider from empty racks, but they do not remove construction delays, financing costs, customer concentration, or the risk that promised capacity arrives after the most profitable moment has passed. Chapter 3. The computer in your pocket changes the equation. Apple now has a 20 billion parameter sparse model designed for its most capable devices. It activates only 1 to 4 billion parameters for a request, using less compute than its total size suggests. Microsoft runs a small language model locally through Windows AI tools. Google's Gemma models are designed for phones, laptops, and tablets. Neural processors are becoming a standard part of personal hardware. Local AI can respond without a network round trip, keep sensitive information on the device, work offline, and avoid paying a cloud provider every time a routine task runs. Summarizing a message, transcribing speech, organizing photographs, searching personal files, or learning your habits can happen where the data already lives. Those are frequent jobs, repeated by billions of devices. The cloud still wins when a task needs the best frontier model, a huge context window, high-quality video generation, enterprise data, or an agent performing many difficult steps. The likely architecture is hybrid. Your device handles private and predictable work first, then sends only the difficult part to the cloud. Local AI becomes the front door. The data center becomes the escalation path. Chapter 4. Efficiency is improving almost unbelievably fast. Stanford's AI Index found that the price of querying a model at roughly GPT 3.5 capability fell from $20 to 7 cents per million tokens in about 18 months. That is more than a 280-fold decline. The International Energy Agency also says electricity per AI task is falling rapidly. Better chips, smaller specialized models, quantization, caching, and smarter software all reduce how much hardware one answer needs. But efficiency has a catch. When each answer becomes cheaper, companies add AI to more products, and people ask for more answers. Agents and video can consume the savings created by smaller text models. That rebound effect is why the IEA still expects data center electricity used to double. Falling cost per task and rising total demand can be true at the same time. Microsoft can be capacity constrained while individual models become dramatically cheaper. The real equation is total demand, multiplied by compute per task, multiplied by the share of work staying in the cloud. Nobody knows all three numbers for a facility that will open years from now. Chapter 5. How an AI boom can still produce stranded assets. First comes forecast risk. A company sizes power and cooling for demand predicted years ahead. During construction, models shrink, chips change, competitors arrive, and customers discover which AI features they will actually pay for. Second comes the lifespan mismatch. AI servers may be refreshed within a few years, while buildings and electrical systems can last for decades. The costly brain can become uncompetitive long before the concrete shell wears out. Third comes location. A useful facility needs reliable power, high-capacity network connections, suitable cooling, and nearby demand. A building in the wrong place cannot fix those weaknesses simply by replacing its servers. Fourth comes finance. New operators use leases, equipment-backed debt, and future customer commitments to grow quickly. If utilization, pricing, or delivery slips, fixed repayments continue even while the expected revenue moves away. Not every builder carries the same risk. A diversified hyperscaler can reuse capacity across many services. A provider with committed customers has protection. A speculative project with weak power access and no anchor tenant is far more exposed. Chapter 6. What happens to a data center that AI no longer needs? A well-connected site can be reused for ordinary cloud computing, storage, scientific workloads, content delivery, private enterprise systems, or a new generation of accelerators. Power and fiber can remain valuable after the first servers leave. Repurposing is not automatic. Different workloads need different rack densities, cooling systems, latency, security, and network design. Upgrading the building can be cheaper than starting again, but it can still cost hundreds of millions. There are three broad outcomes. In the boom case, demand outruns efficiency and almost everything fills. In a correction, good sites survive while marginal projects are canceled. In a hard bust, debt and unused capacity force widespread write-downs. The evidence today points most strongly toward an uneven correction, not a world of abandoned server cities. Demand is growing, but efficiency, local AI, and physical bottlenecks will decide which projects earn their forecast return. For you, this contest determines whether AI is a monthly cloud bill, a feature already built into your next device, or a mixture of both. It also shapes electricity investment and which companies absorb the cost. That is the data center bubble thesis. AI does not have to fail. The bubble only has to build the wrong capacity in the wrong place at the wrong price. Subscribe for technology explained without the hype.